Hello and welcome to Fortinac 8.3 Training, Session 5, State-Based Control. In this session, we will discuss enforcement, the captive networks used, model configurations that need to be configured for enforcement, and host inventory management. In this section, we're going to discuss and understand the access control concepts that the Fortinac uses, as well as discuss how to configure the enforcement. When we talk about state-based enforcement, there's really four primary states that a host can be in the Fortinac database. And starting at the top on this slide and working around clockwise, we have the concept of a rogue. So a rogue is any unknown device. So the icon is a PC with a question mark on the screen. This doesn't have to be a PC. This is any device that is connected to the network that the Fortinac does not know what it is. So it has not been identified, it has not been classified. It is just a physical address that was seen connected on a switch port or through a wireless connection. The next one is non-authenticated. So this is a host that has been identified, it's registered, so to speak, so it's trusted, but we require a host to be associated with that, logged onto that system. So this non-authentication is a host without a user authenticated on it. At the bottom we have disabled, so this is a host that has been administratively disabled, either by an administrator or through a automated process. And on the left we have the at-risk host, and a host is at risk when it has failed a scan. This is either a scan that's been performed by a Fortinac agent, or it's a host that has been marked at risk using what's called an admin scan, and this is the way an administrator could manually mark a host at risk, or through some other process in the system have a host marked at risk as an automated process. Now, it's important to keep in mind as we talk about state-based that state-based provisioning takes precedence over policy-based. We will discuss policies in the next section, but state-based must be resolved before any policies would be applied. Our methods of control are through isolation networks, and those are registration, the quarantine or remediation, the authentication, the dead end, and then there's an isolation network, and there's shared media. So these are all the different networks or VLANs that we leverage for isolation by reason for different reasons. So for example, a rogue, which is unknown, would be isolated to the registration network or registration VLAN if we were enforcing, preventing unknowns, for example, from gaining access to our environment. Quarantine would be where a host that is at risk gets moved. The authentication VLAN is where a host that needs to authenticate gets moved. The dead end VLAN is where a host that has been administratively disabled gets moved. So those top four, registration, quarantine remediation, authentication, and dead end, those align with the four different host states. Isolation is a VLAN that the Fortinac can use for all four states. So it's a single VLAN. So really we have the option, if we're going to start using enforcement and we're going to start isolating hosts of different states, we can have those hosts isolated, each state to its own VLAN. All my unknowns or rogue hosts get put into a registration VLAN. My at-risk hosts get put into a particular quarantine VLAN. Or we can handle any of the states in what we call the isolation VLAN. So that allows us to put our unknown hosts in there, as well as our at-risk hosts if we wanted to, as well as hosts that have been administratively disabled. And then the Fortinac will handle the captive portal web page presentation to present the appropriate page based upon the host's state in that isolation VLAN. And then we have a shared media VLAN. Now, this is also an isolation VLAN, and we're going to talk about how these VLANs work. But this is also an isolation network, but it's a network that allows the Fortinet to control and manage access of endpoints, even if their point of connection is through an item that is not manageable. So, for example, a network switch that is not intelligent. We can still control access. So shared media works a little different, and we'll talk about that in a little bit. And then we have some CLI configuration options. These can be used as a means of controlling access to our environment. That's why or just controlling the way in which a host or the access a host has once it's connected. We can use these CLI configurations to perform a lot of different functions based upon the capabilities of the switch, for example, that the host is connecting by. So we'll talk about the CLI configurations. These can be leveraged while a host is onboarding, say an unknown or rogue host is isolated. They can be leveraged via a policy, which we'll talk about later, and they can also be run as a scheduled task. So these are all our methods of control. And now we'll take a look at some of the basic concepts of enforcement. Pretty much every Fortinet deployment that uses any type of enforcement begins with what we call friend or foe. And it's either you are granted access, the connecting host is either granted access, or the connecting host is denied access. And those are really the two options. A host that connects to our environment that is not trusted is immediately isolated, and a host that connects to our environment that is trusted is granted access. So this is at its very basic, and we're going to see as we expand on this that isolated access we see, that's actually potentially several different isolated networks: registration network, quarantine network, dead end network. And we will see later that the granted access, which we show here as just a single network, could be any number of different networks. And this all runs through the policy engine of the Fortinet. So the Fortinet will see what connects, make a decision on whether it needs to be isolated or granted access. And if it's granted access, it will be able to grant the appropriate access. And if it needs to be isolated, it will isolate to the appropriate isolation network. So as unknowns come on in our onboarding, and this is normally when we would use our registration network, is when a device is being onboarded. So usually that's a guest or a contractor or some form of BYOD. But the device is isolated when it connects because it is an unknown device, and it is directed to the appropriate onboarding portal. So this could be, in this example, we might have a contractor onboarding portal. We might have a guest onboarding portal for guest access. And then once the credentials are entered and they're validated, that host can become trusted and then granted access. So this is the decision table of the Fortinet. So this is the logic, and this is an important piece of information. This is the logic that is used by the Fortinet to determine whether or not a host should be allowed onto the network, and if not, what it should do with it. So when we turn on enforcement, which we'll talk about in the next slide, but when we turn on enforcement, this table is consulted each time a host connects to the network. So if we start on the far left, you'll see that first column is if host state is, and then we have the top four rows are the four different host states, and they are arranged in the order of precedence. So this is how they're evaluated. So when a host connects, let's say an unknown host connects to our environment, it is a rogue device. So we go to that first column, say if host state is, and let's go to the top one, disabled. No, it's not. So then we move down. Is the host at risk? No. So we move down. Is the host a rogue? Yes. So at this point, because the host is a rogue, then the Fortinet moves to the next column over. And you'll see that column is and system group membership is, and it's going to go right down to the rogue row where we match the host state and you'll see it says forced registration. This is a port group. So what these two rows are doing is deciding whether or not this host needs to be isolated. So if the host is a rogue and it's connected to a port that is in the forced registration port group, if both of those are true, then we go to the third column. The Fortinet will change the VLAN for that host to the registration VLAN. So that's how each of these different states work. So if a host connected that was administratively disabled, that would match in the first column. The top row, is the host state disabled? Yes. Then we would look to the right. Is the point of connection a port, for example, that's in the physical address filtering group? Now that's a device group. That's why it says device parentheses. But is the port, the point of connection for that device, is it owned by a device that's in that group? Let's say the host had failed a compliance policy, a scan, so the host is now at risk. Same thing. If the host state is, second row down, at risk, and the point of connection is a port that's in the forced remediation port group, then move it to quarantine. So just read across that top. If host state is and system group membership is, then change to. So that's the decision table for host-based, for state-based isolation. Now, if we look down at the grayed out sections, there is a host state is all, and you'll notice over in the third column it says shared media. We'll talk about that a little later, but that's that situation where we can manage all of those different states in a single, in sort of a single isolation network, and it's done so in a manner that we could have different hosts of different states in the same connected through the same point of connection, or let's say through a switch that is not managed, and have each of them have their own unique experience based upon their state. Now the next one down, all except normal. If the host state is all except normal, you see that is the VLAN is isolation. That's a combination of those top four states in a single VLAN, similar to shared media, but that's intended for a single host connecting on a port, for example, versus possibly seeing 5 or 6 or 7 or many different hosts in the situation for shared media. And then down the bottom we have normal. So a normal state host gets their access granted to either a policy-based, which we haven't talked policies yet, but we will, but a policy-based network or the default. So it's policy-based VLAN or a default VLAN. So and whenever a normal state host or trusted asset connects, the Fortinet will evaluate where that should be, and if it has a policy that says it gets something, such as, say, it's a contractor, and the policy says they should have the contractor network, then we put them on the contractor VLAN. If there is no policy, then they get placed on whatever the default VLAN is for the point of connection. Okay, system groups are how enforcement is enabled. So we talked a little bit about groups back in the first session. And the system groups are where are those groups that enforce something. We had user groups, those groups that we as administrators create. Those are for organizing. So here I've built 4 groups on the left, building 1, and then first floor, second floor, third floor. So actual ports, these are port groups, actual ports have been entered in the first floor group, and ports have been placed in the second floor group, and ports have been placed in the third floor group. Then all 3 of those groups have been nested into the building 1 group. So it's a total of 4 groups there. But what this organization allows me to do is this allows me now to manage on a floor by floor level, or at the building level. I can manage all of those ports in each of the different floors all together by managing the building 1 group. And then over on the right, I have some conference room ports that I've put into a group. And let's assume that those conference room ports are not they're not included in that first, second, and third floor port groups, right? I have not included those when I built those other groups. So they're separate. They're off to the side. Now, when we built all this out, we didn't do anything that's going to impact any end users. We're just organized. We organized our ports. But now, to turn on enforcement, what we would do is we would put those ports into a system group that enforces something. So in this case, I have placed them in the forced registration port group. So that forced registration group is a system group. And if you recall from the previous slide we had with the decision table, we could go down and see what states we would be enforcing on. So forced registration enforces on unknown or rogue devices. So in this situation, what we have right here, if an unknown or rogue device came in and connected into one of our conference room ports on the right, there would be no enforcement. That host would get access to whatever network or VLAN that port was on. So there would be no, the Fortinet would do nothing to control that access because those ports are not part of a system group. If that same host then moved from the conference room and plugged into a port that's in the first floor port group, now you would have and we're assuming this host is a rogue, it's unknown. Now you would have an unknown host plugged into a port that is inside of the forced registration group. And if you remember from the decision table, if a rogue device is connected on a port in the forced registration port group, then the Fortinet is going to change that device from whatever VLAN it's on now into the registration VLAN, because we are not allowing unknowns to connect. And the way that process works is in a wired environment. That's all we'll talk about right now is wired. We'll talk about wireless later. But in a wired environment, the host would connect. The Fortinet would see the host connect. The Fortinet would evaluate or look in its database, say, do I know this host? And if the host is in there as a rogue, or if it's not in there at all, it will be added as a rogue. Then the Fortinet goes, okay, I have a host that is unknown. It has a state of rogue, and it is connected to the port, the first floor port. It then evaluates the system group. Is that port in forced registration? The answer is yes. So we have a positive as far as the point of connection. We also have a positive for the host type. It's a rogue in a forced registration port. Now the Fortinet connects to that switch, and it will shut down the port that the host is connected to. This will cause the link to drop. Then the Fortinet flips that port into what has ever been designated as the registration VLAN, and it will bring that port back up. And that port comes back up, and the host regains its connection, and it now prompts for that forces the host to then say, hey, I need a new IP address. So that host now issues a new DHCP discovery because it thinks it is just reconnected. And now that it's in the isolation network registration, the Fortinet is going to be the DHCP server. If we had added a couple of these second and third floor ports to another system group, in this case forced remediation, now this is the group that's associated with hosts that are at risk. So let's go back to that first example, an unknown host. Let's say it's a contractor's system. An unknown host connects to the first floor. The port is dropped. They are moved into the registration VLAN, and the port comes back up because they're unknown and they're in the forced registration, connecting in a forced registered port. They then are captive portaled, and let's say as part of the captive portal process, we require them not only to have valid credentials, but also to scan with a Fortinet agent to validate that their host is compliant. So let's say that scan failed. They are not compliant with our requirements. Well, if they're in the first floor, that's fine, because based on what we have set up here, we are not enforcing on at risk in the first floor. You'll see, because that is not part of the forced remediation port group. But if that host were to connect in a port on the second floor, then the same thing would occur as when the registration took place. The port would be dropped, the port would be moved into, the port would be shut down, I should say, the link would drop, the port would be moved into the quarantine VLAN, and then the port would be brought back up, and now the host would be in the quarantine VLAN and forced to remediate. So in the second and third floors, we're doing both states. We've got those ports in two groups. They're in both the forced registration and the forced remediation port group. So if an unknown host connected to the second or third floor, they would have to go through both processes. They would have to onboard, and become a trusted host or a known host, then they would have to also be in compliance in order for them to then be moved to whatever production network they were supposed to be on. So once they're in the isolation network, this is how the Fortinet forces them to an isolation page. So starting on the left, you'll see that port came back up after the Fortinet moved the host to the isolation network, and that prompts the end station to issue another DHCP discovery saying, hey, I need a new IP address. I've just connected to a network. And the Fortinet is the DHCP server. So that first point starting on the left of this timeline is the Fortinet hands back an IP address appropriate for the isolation network that this host is in. It also hands back a DNS address. And that DNS address that it hands back is itself. So the Fortinet says, I am your DNS server. Then when the host attempts to go to a website, for example, and does a DNS lookup for that website, then the Fortinet will be the one that's going to respond to that, and it's going to use a root hint file. In the case of registration, it would be called root.hint.reg. And it's going to look in a list that is called the zones.com and determine if the site that the end user is or the end station is attempting to access, if it is an allowed site. And if it is, then the Fortinet will proxy the request to a real DNS server and return the appropriate response so that the host gets a valid IP to get to the site they're trying to get to. But that's only a small set of sites. Most of the time, when that host attempts to go somewhere, the Fortinet is not going to see where they're trying to go in that list, and it's going to respond back with itself as being that site. So for example, the host tries to go to site A. A is not in the list. The Fortinet says, I'm site A. The host tries to go to site B. That is not in the list. The Fortinet responds back and says, I'm site B. So every time the host tries to do a lookup to go to a site that is not in the list, it will get back the Fortinet telling it that it is that site. Then Apache and Tomcat Portal are used to present the page to the host. So anywhere that host tries to go, with an exception of a handful of sites, anywhere that host tries to go, it's going to keep getting that same page. You must agree or disagree, or you must register. It depends on how the portal has been configured. And this is how the captive portal process works. So to summarize, start to finish, host connects based on the host state and the point of connection. The Fortinet has determined the host needs to be isolated. The host is moved into the isolation network by the port being shut down, the VLAN being changed, and the port coming back up. And then once in the isolation network, the Fortinet is the DHCP server, and in almost all cases, it is also going to be the DNS server. And, well, it is always going to be the DNS server, but in most cases, any DNS lookup is going to be the Fortinet. So the Fortinet is essentially going to wildcard and keep directing the host back to itself, to the Fortinet, for this portal page presentation. Here's a nice screen to help you determine whether or not you have enforcement everywhere you want to have enforcement. So in our topology view, you can right-click on the root container, and there's an option for Control Access Network Summary. And what this is going to do is this is going to show us exactly where enforcement has been turned on. So you'll see each gray bar. First off, at the top, it says registration. So that's the type of enforcement we're looking at right now. Where is registration applied? And that means, where am I not allowing unknowns to connect? Where am I enforcing against rogues? So the gray bars show us the different containers that we have in our topology tree. And then under the gray bars, we see the different infrastructure devices that are contained within those containers. So you'll see building 2, if you follow across the gray bar on the far right, it says it's 100% enforced. But then within building 2, that container, we see switch 2. And switch 2 says it's 50% enforced. So at first that math seems odd, but the way it works is at the container level, building 2, that is what percentage of infrastructure devices in that container have some level of enforcement. And there's only one switch in building 2, and that has some level of enforcement. So that's where we get the 100% of the infrastructure devices within building 2 have some level of enforcement turned on. Then if we look at switch 2, you'll see 50%. So 50% of the ports, for example, have enforcement turned on. And you can see all the others going down. So this is a great screen. After you've started to enforce and lock down the network, you can come in here and make sure you haven't missed anything. Make sure there isn't accidentally some switches that were left out of enforcement and thus are a security risk because someone could connect and gain access through those. Here I've gone under my system settings, so under the system menu into the settings, and on the left hand side I've opened up the control folder. And here we're looking at the allowed domains list. So remember how the isolation works. When a host has been isolated, they've been moved into, say, the registration VLAN, and the Fortinet is acting as the DNS server. This is where we identify the allowed domains. So these are those domains that a host will be allowed to resolve correctly. So up at the top, we have an IP address. That's our production. We can have more than one, semicolon separated. So those are our production DNS servers. And then there's a proxy auto-config section. If you leverage a proxy, we can make sure we leverage that well in isolation. And then at the bottom, we have our list of domains. So these are the sites that if a host does a lookup against them well isolated, that the Fortinet will forward their request to the production DNS, that's designated at the top here, and it will respond back to the host with the appropriate or real IP address of that particular domain. So this is to allow hosts that have been isolated to get to certain sites. And the sites we have listed here, there's a lot of different reasons we have these sites listed. You'll see there's a total of 202 different sites I can get to. These typically are allowed because of remediation needs. So let's say a host has been isolated because they're out of date on their antivirus definitions. We want to be able to allow them to update those virus definitions. And so there's a lot of these sites that they may seem to have, no real relation to why you would ever need to remediate or you would need to get to in order to remediate. But this has been a long time this list is being built, that sites have their updates and access to new versions of, say, antivirus software and things. They spread them out across a lot of different sites. So over time, this list has grown to include all those necessary sites for remediation. Now you can remove from this list, as you can see with the buttons at the bottom, and you can add to this list. You also have the ability to revert back to defaults. But basically, this is saying what sites are going to be allowed from within isolation. And the quarantine option on the left is where we can turn on quarantine VLAN switching at a global level. So remember, quarantine VLANs, the quarantine VLAN is used when an at-risk host, so a host that has failed a Fortinet scan performed by an agent, when a host has been deemed at risk and they're connected into a port that is part of the forced remediation port group, then they would be moved to the quarantine. But this is a global setting, this enable quarantine VLAN switching. If this is not checked, then the Fortinet will never isolate a host because it's at risk. If it is checked, then if that host is in a port in the forced remediation group, then they will be moved. And you'll see just below it, we have a set all host risk state to safe. That is a single click button to take all hosts that have been deemed at risk and make them safe. This is a tool that you use in the event that through a misconfiguration, say with a scan requirement, you've accidentally marked a bunch of hosts as at risk. So you've created a scan, and that scan isn't functioning as expected, and instead it's marking a lot of hosts at risk. This is a way to come in and get them all back to safe so that they're not isolated. Now we'll take a look at the two primary deployment options for our captive networks. The first is a layer 2 deployment, or we often call this a flat deployment. And in this type of deployment, we have each isolation network is just one big flat network. So we have a registration network, for example, and it spans throughout our entire environment. So it's one large broadcast domain. It's one big VLAN that is used at every location for registration. And when we do this type of deployment, the configuration on the Fortinet configures its captive portal interface, which is typically Ethernet 1, to be a trunk port, and that would connect into a trunk port on the infrastructure. And there would be a VLAN interface that connects to each of the different isolation VLANs. So if we had a registration VLAN out there, for example, that was VLAN 110, we would have an interface on ETH1, a sub-interface or a VLAN interface registration. In this example, 192.168.110.2 is the IP on that interface, and that interface would be on that VLAN, and we would have the same for any of the other isolation VLANs we would configure. In this type of scenario, we now have a presence, so to speak, on every isolation network, because the main goal here is that Ethernet 1 and the Fortinet Ethernet 1 specifically is going to be the DHCP server and DNS server on that isolation network. So in a layer 2 type deployment, in this case, I'm using the example of registration VLAN, and it's a green dashed VLAN. It's one large flat network. So it's the same, that VLAN spans across building 1, building 2, building 3, and the Fortinet itself off of Ethernet 1 has an interface sitting on that VLAN. So if a host were to connect and be isolated in building 2, for example, when the port came back up and the host requested a new IP address, its DHCP request would be seen by that interface of Ethernet 1 sitting on the registration VLAN, and then the Fortinet would respond with an appropriate IP address from a scope configured on the Fortinet, and it would also respond with its own interface as being the DNS server. So in this example, you can see the IP handed out will be 192.168.110.100 to 192.168.110.200. So that is our registration scope. And then we see that Ethernet 1 has an IP address of 192.168.110.2. That's the interface on that VLAN, and that would be designated as the DNS server to the host. The other option is called a layer 3 implementation or a layer 3 deployment. And in this situation, the Ethernet 1 of the Fortinet is just a regular access port, and it's connected to a port on a particular VLAN, and very often it's like a stub VLAN. So in a lot of the environments, there'll be two things on that VLAN, the Ethernet 1 of the Fortinet and the gateway. And then all of our isolation networks, they can be any number of them out there, and they don't have to be the same VLAN at all. They can be completely different VLANs. The Fortinet does not care. ETH1 on the Fortinet is configured with a IP address, all in the same subnet, but it would have multiple IP addresses on Ethernet 1, one IP for each of the different isolation states. So say registration and quarantine, we can see here it's 192.168.210 and 200.11 are two IPs there, and I also have a dead end authentication. But it's still, just like before on the layer 2, it still requires the Fortinet to be the DHCP server, and it's going to be the DNS server. The only difference here is we're going to use DHCP relay. to make sure that an isolated host out on one of the isolation networks we've set up out in our environment, when it requests a DHCP address, that address comes back to the Fortinac. So in this example, we have 3 different registration VLANs. So I've indicated up on building 2, there's sort of a blue dash line that's supposed to indicate that registration VLAN, but that registration VLAN doesn't go anywhere beyond that one environment. So it's not spanned throughout my whole environment. And then I have a different registration VLAN in building 3 and a different one again in building 1. So I have 3 different registration VLANs. None of them are spanned anywhere or tagged or trunked beyond their local environment. And then the Fortinac ETH1 is sitting on VLAN 200, we'll say, in this example, and it's going to have a scope for each of the remote VLANs. So now when a host connects, for example, in building 2 and is isolated to the registration VLAN, and it requests an address when the port comes back up after the VLAN changes occurred, that request is going to be forwarded using a DHCP relay all the way back to Ethernet 1 on the Fortinac, and the Fortinac is then going to respond with an address, an appropriate address from the appropriate scope for that building 2 environment there, with itself as the DNS server. So in this case, 192.168.200.something is going to be the DNS server for any of the hosts in the isolation networks. And now it all works the same after that. A host attempts to look up a domain or do a DNS lookup, and it's going to talk to the Fortinac, and the Fortinac is, in most cases, unless they're going to one of those allowed sites, the Fortinac's going to respond with itself as being the site the host is looking to go to. And that would result in the presentation of the isolation portal page, in this case, registration page. Access point management is also called shared media. This is a configuration that allows the Fortinac to enforce different types of isolation, for example, registration or quarantine or dead end. Enforce that on hosts that are connected through a switch that has no management capabilities. So in order to do this, the Fortinac needs to do it at layer 3. Because there is no layer 2 capability, we can't change VLANs on the ports of this unintelligent switch. It's got to be done at layer 3. So the way this works is the unintelligent switch is connected back to another switch that is hopefully managed, and that uplink to that switch is placed in the shared media VLAN, which is an isolation VLAN, just like registration and just like quarantine. It's just like that. And the Fortinac ETH1 is still going to be the DHCP server and the DNS server. The thing is, in this configuration, we're going to also allow hosts out to the world, normal state hosts, so we can allow access for normal state and still force to a registration page, for example, for an unregistered host, even though they're on the same switch that has no management capability. And how this is done is when the host connects to that unintelligent switch and issues a DHCP discovery and says, hey, I need an address, the Fortinac will look that host up in the database and find out what state that host is. So let's say this is a normal state host. Well, and it should be granted access. Then the Fortinac will respond back with an IP address appropriate for the shared media VLAN, but it's also going to be an authenticated address. So basically there's 2 pools. There's 2 IP pools, and one is for authenticated or normal state hosts, and one is for non-normal state hosts. So there's 2 choices. You're either a normal state host or not a normal state host. So in this case, the Fortinac responds back to the normal state host with an authorized IP address from a range, let's say in this example, 192.168.114.10 to .100. So it hands back an address in that range, and it hands back a real DNS server so that host can now tries to go out to Google or Yahoo or Fortinet.com, and it will resolve correctly and be able to get there. Then if a non-normal state, let's say an unregistered or unknown device, connects into that same switch at the same time, it's going to ask for an address. And the Fortinet is going to look it up in the database and say, okay, I don't know who you are or what you are, so you are a rogue. So I will give you an address, but I'm going to give you an address from a different scope, an unauthorized scope. And what we would normally do is have a whole another subnet. So we would hand back, say, 192.168.117 dot something. And we would essentially be supporting two different subnets on the same VLAN. So your gateway would have you'd have two gateways. One for each subnet, and they would just share that same VLAN. But now this non-normal state host, when it would get its address, but it would also get the Fortinet as its DNS server. So when it attempts to go out to Google or something like that, then just like in the other captive environments, the Fortinet is going to respond saying, I, the Fortinet, am that site you're trying to go to, and then the host will connect and get the isolation page appropriate for that host state. So it works a little bit like that isolation VLAN that handles all the different states. So we could have a normal state host with access to the world. Then we could have an unknown host getting forced to the registration page. We could have an administratively disabled host getting forced to the dead end page, all off the same switch, because the same unmanaged switch, because the normal state host would have an IP and DNS from the authenticated pool, and the two non-normal hosts would have an IP address from the non-authenticated pool, and they would be given the Fortinet as their DNS. And anytime they tried to go, the Fortinet would determine, based on what their state was, which page to give them. Now here we see the IP ranges listed. This is not where you list out the IP ranges that will be handed out. That's done through a configuration wizard during initial installation. But what these IP ranges here, or this one you see, is 192.168.114.10 to 192.168.114.100. What that is that's a way to help prevent an end user from potentially statically assigning an address to themselves from the authenticated pool when they're not in fact an authenticated host. They say an at-risk host or a rogue host. So what this does, remember, the Fortinet knows IP and layer 2 information. We got that through our visibility, L2 polling, L3 polling. So if the Fortinet sees an address in this range, so this range is our authenticated address pool, if we see a host with an address in that range in the database, we're going to check the lease file and make sure that the Fortinet, it's going to make sure that it gave out that IP to that physical address based on the lease file. If it did not, then it knows that that host has that address from some other means, probably statically assigned. And we can set up an action, as you'll see a little later. We can set up an action then to disable using MAC filtering on that switch to prevent that user from gaining access because they self-assigned an address from the pool they should not have gotten assigned from. The CLI configuration is another tool that can be used for a real large number of different tasks. It's supported on the vendors you see on the left there. And basically what this is the ability for the Fortinet to log into an infrastructure device and issue commands on your behalf. So here we've got an example. This was a real-world example, probably not something you would see often, but just an example of how this would work is you'll see there's one entry called change port speed. So that entry was added by clicking on the add button. And if we were going to rely or require some MAC address information, we would need to select the appropriate format from the drop-down up at the top there. Then I gave it a name, change port speed. Then in the commands to set, what I did here is I typed the commands as if I were logged in to the device that this is going to be used on, and I was already elevated access so that I could begin configuration set commands. And I did a config T, and then I hit a return, interface, fast Ethernet, and then I used a variable, %port %. That's over on the right side. You see there's 4 variable buttons. I used a variable. That means the Fortinac's going to insert the appropriate value there, depending on how I'm going to have this CLI triggered. And then I have set the speed to 10. Down below, I have the commands to undo. So again, config T, and then I did the interface fast Ethernet with a port variable, speed, auto, for auto negotiate. And you'll see I gave it a just quick and simple description, changes port to 10 meg and back to auto. So now where this could be used, there's 3 places we could use this. We could use this as part of the onboarding process. So let's say an unknown host connects to the network. The Fortinac sees that host come onto the network, and that point of connection is in the forced registration group, so that we're enforcing registration or isolation of that unknown host. So the Fortinac would shut the port down. The Fortinac would change the VLAN to the registration VLAN. It would then carry out the commands to set in the top part of this screen for the appropriate port that host was on, and then it would bring the port back up. And now that host, while it's in the isolation or registration VLAN in this case, would be set to a speed of 10. But once the onboarding had completed, so the host has successfully registered, the port would drop down again, would be shut down again, and the Fortinac would change it back to whatever VLAN it should be on. Maybe it's a contractor, so it's going to go to the contractor VLAN. And then before it brings the port up, it's also going to go, or as it brings the port up, it's going to go and do the undo command. So it's going to set the speed back to auto negotiate. So basically the whole time you're in that isolation network, you're at a hard set 10 meg. And once you come out of that network, you're back to auto negotiate. Just as a sort of teaching example of how this CLI tool can be used, it allows us to really leverage any of the capabilities of the edge device as a script. So another place this can be used, other than say during onboarding, is this could be used as a part of a policy. So when we talk about policies, you'll see we could have one of these CLI configurations set up so that when a host that matches a particular policy connects to the network, we can have a specific set of instructions entered on the edge device, and then when that host leaves, we can undo those settings. So this allows for dynamic configuration based on who, what, where, and when information when the host connects. The third place CLI configurations can be configured is in the scheduler. So we could schedule the commands to set to be carried out on a group of devices. You would need to designate that group of devices. And then you set a scheduled time. And when that scheduled time arrives, the Fortinac will go out, log into each of the devices in the group you've designated, and carry out all of the commands you've listed. Now, there's a couple caveats to keep in mind. First, if you're using the CLI as this CLI tool with the scheduler, there can be no variables. So you can't add any variable information because there's nothing really triggering that to occur other than the scheduled date and time. And the other thing is the commands to undo at the bottom are ignored by the scheduler. So if you want to have something, some commands set, and then some commands undone later, you would need to build 2 CLI configurations, only filling in the commands to set portion for each, and then you would schedule them to occur at different times. Okay, some network device settings. We've already seen this configuration page in a previous session. But we did not talk about all of the different settings. So I'm just going to because we hadn't talked about what they wouldn't have made sense at that point in time. Now we're going to talk about those settings that we had skipped over before, now that we know how the process for isolation works. So first thing, we'll take a look at this registration delay. So a registration delay is how long the Fortinac will leave a host in the registration network upon a successful registration or authentication for onboarding. And the whole purpose of leaving them there for 5 seconds after they've submitted their credentials and those credentials have turned out to be valid is so that the Fortinac has time to redirect the end user to a success page so that they can see that they have successfully done what they needed to do. Next, we'll take a look at a VLAN reset delay. So what does this work with? So this is tied to two different system groups that exist in our groups view. And one of the system groups is called reset forced registration, and the other is called reset forced default. So these are port groups. That's two different port groups. What this does, when you have a port in the reset forced registration, what it does is when a host disconnects from that port, 60 seconds later, the Fortinet will flip that port into the registration VLAN. And very similar with the reset forced default, what that does is when a host disconnects from a port, that port will flip to the default VLAN, whatever that's been designated for that port. So that's the delay for those two different port groups. The VLAN switching delay is how long the port is held down. So when the Fortinet is changing a VLAN, it shuts the port down, changes the VLAN, and brings the port back up. The default setting for that is 8 seconds. So the port will be held down for 8 seconds. This was a value, this is the lowest value through testing that shows all operating systems giving up with their old IP they may have had and asking for a new one. In this next section, we'll take a look at the model configurations that need to be set in order to enforce access control. For each infrastructure device in the topology tree, like a switch or a wireless controller or access point, you're going to be able to select it, right-click, and down the bottom there'll be a model configuration option. There's also a global model configuration option there as well. So here we've selected the model configuration, and you'll see it's the resulting page is broken up into several sections. Not every model configuration is going to look exactly like this. They're going to vary. These pages are really put together, so to speak, based on the type of device that's selected. So very often you will see fewer options than you see in this example. Typically, you're always going to see a general and a protocol section that you see at the top. Those will already be configured most likely because that's when you initially modeled the infrastructure device. You filled that information in. The next section down here labeled network access. Here is where we define the isolation VLANs for the different isolation networks dependent upon state. So our registration VLAN is set to 110. Our quarantine is 111. Our dead end is 112. We aren't enforcing authentication anywhere, so we don't have an authentication VLAN selected. You'll see at the top the VLAN display format. We can go by VLAN name, by VLAN ID. We can manually enter a value. Those options won't always be there. Again, that depends upon what type of device it is that we've gone to the model configuration on. You'll also see there's a default, and that's the default VLAN. That is for each of the individual ports on this particular switch. So an important thing to keep in mind is that when we set an isolation VLAN, that is being set for the switch as a whole, where when we set a default VLAN, that is being set port by port. So by default, whatever VLAN a port is on when it's the switch is initially discovered, that's going to be set as that port's default VLAN. That can be changed at any time from the topology view or from the port properties view. We can also change it here, but if we set a value for that default setting, that is going to set that value for every port on the switch. So that may not be what you want. So it's important you're aware of that. The next section down, we see voice VLANs. You won't see this on a lot of devices, but when we go through and try to determine a default VLAN when initially modeling the device, on some switches, the Fortinet can't identify a voice VLAN versus a data VLAN. And it's not common, but if there is a situation like that, then that type of switch will have this entry or this section where we can list our voice VLANs, and that'll just ensure that the Fortinet does not accidentally choose the voice VLAN to be the default VLAN, because when we're talking about default, you're talking about a data VLAN. Just below that, we have our CLI configurations. Now, we just recently talked about CLI configurations, and one of the ways we can leverage those is through the onboarding process, and that's where we can decide to use them, is right here. So here it's set to none, but if we were to go and select port-based or host-based, we would get a pop-up that would allow us to choose which CLI configuration would be carried out as the host was being isolated or coming out of isolation when it would do the undo. The difference between a port and a host-based is the port is typically something's being done to the port at the port level, where the host-based is where we would potentially be creating ACLs on the fly. That's why there's a button there, applied ACLs, to see what ACLs have been applied. Because what we can do is have basically the CLI have entries for an ACL, and then when this CLI configuration is invoked, it goes out and adds those entries into the ACL, and then when the host leaves, it could go and take those entries back out of the ACL, probably keying on IP address, for example. So the other real difference between the port-based and the host-based is, remember the process of isolating a host. When a unknown or rogue device, for example, connects to a port that's in the forced registration port group, the Fortinet will shut the port down, change the VLAN, bring the port back up. Well, when we're dealing with host-based CLI configurations, the shutdown of the port doesn't occur. The port stays up the whole time, because we're assuming that the captive environment is going to be presented due to because of ACLs that are being used. Just below that, there's detail configuration. Again, you may not see this on a lot of switches. Secure port is enabled for ports on this device. If you've got that option, you can select that. Enable radius authentication, so we can use that. And then there's also roaming guest information, so we can leverage the roaming guest capabilities, which we won't talk about right now at this point. Now, setting those configurations on every single device, if you have a large network with lots of devices, would take a lot of time. So there is this option, global model configuration, and this is going to allow you to select one or more devices at the top and then fill out all the information one time. And when it's all filled out and you apply it, it applies to all those infrastructure devices. So you could very easily, if you have a fairly homogeneous environment, you could select 50 different switches and in just a matter of moments have them all set to what you want them to be set to here. Now you'll notice there's two radio buttons up there: save all values for selected device models, and we have save only changed values. So this is so we could come back and revisit maybe later and update a username and password, and it's only going to update those values, or update an individual VLAN ID for the isolation networks or something like that. It's only going to apply the changed values in that situation. So this is an example of turning on enforcement in a wireless environment. So with wireless, we don't have physical ports to put into the forced registration port group, for example, or the forced authentication port group, or the forced remediation port group, the way we enable or turn on enforcement in a wired environment. So what we do here is, you'll see down the bottom it has network access. We select which of the different states we want to enforce on. So dead end would be enforcing on a host that has been administratively disabled. Registration would be for an unknown or rogue, and we can set them to bypass, which means they'll be that state is ignored. You don't care about that state. It could be set to enforce, which means the host will be isolated if it is of that state, and we can set them to deny, which means that a radius reject will actually be sent when a host of that state attempts to gain access. So when you select which ones you want to enforce, then there's a drop down field over in the access value, and that's where you will select the value you want passed back to the wireless controller in the radius packet. I'm going to talk more about how this works in a wireless environment. But essentially what happens is the FortiNAC passes back the access information in the radius packet, and what you select from that dropdown will be the piece of information that is inserted into the radius response in a isolation situation. Now, these settings we see right here are global. So for this, it's going to apply to all the SSIDs on this particular controller, which may not be what you want. So we have the granularity. If you go back to the topology view, and under the SSIDs tab, we have the ability to go in and select any individual SSID in the list and right-click on it, and there'll be an SSID configuration. And you'll see these settings are the same pretty much that we just saw. We can choose to use a different radius server, for example, and we can also choose what we want to enforce or bypass or deny access, and we can do it at the SSID level. So we have that granularity, and that's very often what would happen in a real environment. You would set up an SSID to test on. You'd get it all set up, make sure everything was working the way you wanted before you started then applying that across multiple SSIDs. In the last portion of this session, we'll take a look at how end users can manage their own host inventory using the host inventory management feature of the FortiNAC. This feature is enabled via the portal configuration pages. So under the system menu, there is an option for portal configuration. Select that option, and then on the left-hand side in the content editor portion of the screen, open the global branch and select settings. Within the settings fields, you will change the success page type to be host inventory. So what this will do is it'll present a login page, just like it would if they were onboarding a device, like registration. But when they successfully submit valid credentials, instead of going to a page that says they successfully registered, it's going to bring them instead to a host inventory page. Now, the details of this host inventory page can be configured on the left-hand side of the screen in the Content Editor tab. At the very bottom, there is a host inventory branch. And we can open that up and we can decide what information we want presented to the end users when they log in, as well as what their capabilities are once they have logged in. And the end result will be a page similar to this, where the end user could register another host directly from this page, or they could delete a host that is already registered. So we most often see this in university or education environments where students may have 3, 4, 5 different things that they bring in and connect to the network. But at the same time, to keep licensing under control, the university may only allow them so many items per student. And a student may either use all those licenses up or attempt to exceed them, but they won't be allowed to, and they might get a new device, maybe a replacement laptop, for example. Well, instead of having to go through someone in the help desk, for example, to go and remove their old laptop that they no longer own and add their new one, they can do that for themselves right here. So what you would need to do is make the login page available to the end user after you've set it up through the portal configuration. And one other side note on that portal configuration, you can have as many different portals as you want. And we'll talk about that in the next session. But you're going to want to have a portal page that is just for the host inventory management. You would not want to use the default portal. The default portal still needs to be configured so that users can onboard when they initially connect to the network. And this inventory page would then be set up through a separate portal, probably called host inventory portal or something like that. And we'll see how we create different portals in the next session. Now, once this portal is created, you would then need to make the page available, the login page available from the production environment. So on an internal website or something, IT services site or something, this is the URL you would need to make available. So you could have this URL sitting behind, the word here in the sentence, click here to manage your inventory. And you'll see it's HTTP // the Fortinac. So that's the fully qualified domain name of the Fortinac. And this is all case sensitive /registration /validuserlogin.jsp, and that's a capital VUNL. And then after JSP, we have a question mark, portal name, that's a capital N, equals the portal name that you created to be your host inventory portal. And then a user can go to that page and would be told, click here to manage their inventory. They click there. It's going to bring them a login page with a username and password. They enter their information, and when they submit it, if it's successful, then they would get this management page and then have the ability to manage their own devices. And that completes this session.